Yeah, this is Dr. J. Mohan, EC Department from Institute of Aeronautical Engineering. We discuss about the signals and stochastic processing in this subject. Now we can discuss about the subheading of example of Fourier series. Last class we studied for the Fourier series properties. Now this class we go for the Fourier series examples. First example, we received for the signal. That signal is represented as a periodic signal. Its a fundamental period is equal to capital letter T. In the Fourier series, always we take for the x of t as a periodic signal and the fundamental period is equal to capital letter T. Then only it's possible to do for the Fourier series. Well, before going for the analysis, we must verify the signal is going to satisfy for these two conditions. That means x of t as a continuous time signal, it's represented as a periodic signal. At the same time, fundamental period is equal to capital letter T. So, in this example, we represent for the signal, that is a Fourier series, the fundamental period is start at 0 and it's ended for the 2 pi. After that, next 2 pi to next 4 pi is represented as the same character of signal. So now that case, we take for the input signal, that is we receive for the Fourier input signal is f of x, that value is equal to x and 0 less than of x less than of pi, and pi is represented as a pi less than of x less than of 2 pi, and as period we represent as a 2 pi. That means the capital letter T equal to 2 pi. Okay, in the sum they given. So finally we represent for the example is applying the Fourier series of following function is defined in 0 to 2 pi. F of x equal to x 0 less than x less than of pi and pi less than of x less than of 2 pi. Now you see 0 to 2 pi is going to happen. Then it's how the half of the signal, that is 0 to 2 pi is represented as 0 to 2 pi. We represent as y. This portion we call for the x of t, x. Okay. In the sum they are going to given. This is f of x. So we given. So this pi to 2 pi they given pi. So two different cases of signal we there given. 0 to pi is one thing and pi to 2 pi is another thing they given. And has the fundamental period we given for the we received for the 2 pi in the sum. Now we know the trigonometric Fourier series. Okay, we know the trigonometric Fourier series. We take for the trigonometric Fourier series as to solve this sum. For the trigonometric Fourier series is represented as a x of t is equal to a0 plus summation of n equal to minus into plus into a of n cos omega 0 n t plus b of n summation of n equal to represent by the summation of n equal to minus into plus into b of n sin omega 0 n t we write. Okay, so this a0 an bn, this is trigonometric Fourier series. Okay, trigonometric Fourier series a0 an bn are trigonometric Fourier series coefficients. Okay, so now we need to find for the a0 an bn. So a0 we know, as when we studied for the trigonometric Fourier series, I said a0 is equal to 1 by, that is 2 by t, that is a0 is equal to 2 by t integration of the interval between the total signal 0 to 2 pi, or we write for like this one 0 to t and f of x, that is called for the x of t, dt we write. Okay, x of t dt we write. So if we say x, then I should write for the x here. Because of what they consist. So here we represent for the t. So previous, that is a general case. A0 equal to 2 by t, 0 to t, x of t dt. We write for the x of t and dt. I should write for the normal x of t dt. Here t is z, that's why we will do. Here is x is z, we can write it for like this. According to the case of sum we received, we may write it for the equation. Now a0, according to the sum we received f of x, then a0 is equal to 1 by t integration of 0 to 2 pi f of x dx we write. Okay, this is represented as a Fourier series coefficient of a0. Then what will be represented 2 by t, this 0 to 2 pi is there, then it's represented as a 2 by 2 pi, it will be 1 by pi we got. So what the limit present, x is present for the 0 to pi f of x dt. Next 1 by pi to 2 pi f of x dt. Now we can substitute these values. Okay, now this interval we have for the 0 to pi is represented as x, we write it here. Pi to 2 pi we write it here. So 1 by pi integration of 0 to pi is represented as x dx plus 1 by pi integration of pi to 2 pi dx we write. Now 1 by pi, that will be represented as a constant. This integration x dx is x square by 2, 0 to pi, the interval. Then pi to, that will be represented as a 1 by pi. Okay, this is 1 by pi. So here is pi is there, that's why I take it out for the outside here. Okay, pi. These two are getting to cancel. Then integration is represented as a dt, that is 0 to 2 pi dx is there. That's why what will be represented x pi to 2 pi we may write. Then we need to substitute for the all intervals. Okay, these two are getting to cancel. We need to substitute all in 1 by 2 pi. This is pi is represented pi square divided by 2 minus of 0 plus. It is 2 pi minus of pi. Now we need to simplify for all the values. So what is it? This is 0. That's why what will be represented? Pi square divided by 2 pi is there. Pi is cancelled. Pi by 2. So this is 2 pi minus of pi is represented as a pi. So we get for the pi. So pi by 2 plus of pi. A0 is equal to, we can multiply, cross multiply for this 2 and add for this one. 3 pi by 2. A0 we got for the 3 pi by 0. Then same like that one. We need to find for the a of n. So a of n also is represented as a 2 by t. Okay, 2 by t. So 2 by t in the sense t is equal to 2 divided by 2 pi, we write as a 1 by pi. So this is 1 by pi integration of 0 to 2 pi f of x cos nx dx. Okay, cos nx dx we write. So based on the x is there, that's why we write for the coefficient of a of n. Then now need to substitute for the values. What the value? 1 by pi is there, 0 to pi x is there, that is cos nx dx plus 1 by pi integration of pi to 2 pi cos nx dx we write. So now we can make to do for the integration for this one. If we do integration, we got like this form. That is 1 by pi. This integration is represented as a pi sin n pi minus of 0 sin n0. After substituting the limit, 1 by pi, 1 by n is present, minus of cos n x divided by n square 0 to pi plus 1 by n sin n 2 pi minus of sin n pi x. Here it is represented as the integration of uv dv condition is there. So x and cos n. So that's why we do for like that one. After completion of this case, we substitute for the completion of integration, substitute for the 0 to pi. Then this case 0 pi to 2 pi we make to integrate. Then that pi is constant, take it out. This 2 pi are getting to cancel. After that we can substitute for the interval. After substituting the interval, this term is represented as 0. Okay, sin any pi is represented as 0. That's why I write as a 1 by pi. This term, this is 0 into multiplication. This whole term is represented as 0. Then this term is represented as cos n pi by n square minus of cos 0 divided by n square plus 1 by n. 0. This is 0. This is also 0. These two are getting to cancel. So now these are getting to cancel. Okay, but the case of 1 by n square pi cos n pi minus of 1, the cos 0 is represented as a 1. So this n take it out, then what will be represent? Cos n pi minus of 1 is that 1 by n square of pi is represented. Now a of n. Now you can substitute for here odd value. N is represented as odd value. Its produced output is minus of 2 by n square pi. If you substitute n is a even value, it's represented as 0. Okay, this is the first Fourier coefficient, Fourier series coefficient of a of n. Next, second Fourier series coefficient b of n is equal to, as like a formula, 1 by pi integration of 0 to pi 2 pi, then f of x sin nx dx we write. So we need to substitute for this values what we have received from the sum. First is x, another one is a phi. We can substitute. This is making to use for the UV integration method to simplify for the equation and substitute for the intervals. So 1 by pi take it out. This case minus of pi cos n pi divided by n minus of 0 after substituting the limit. Then sin n x divided by n square. Limit is 0 to pi. Then minus of 1 by n cos 2n pi minus of cos n pi after substituting the limit. Then we can simplify for this equation. We get it for the b of n is equal to minus of 1 by n minus of 1 whole power n plus 0 minus of n minus of 1 by n 1 minus of minus 1 whole power of n. So that is equal to b of n equal to, after cancelling for all the values, which one is going to have similar, we can cancel b of n equal to minus of n. Now we should write for the trigonometric Fourier, that is a trigonometric Fourier series equation f of x equal to a0 divided by 2 plus n equal to minus 1 plus a of n cos n x plus b of n sin n x as per the as per received sum. Based on that one, I write for the equation for trigonometric Fourier series. Now a0 equal to, we find 3 by 2 pi. an is equal to 0 for n is equal to 1. But minus of 2 by n square pi n is equal to b of n is equal to minus of n. We substitute for the case, we get for the Fourier series of trigonometric condition. Okay, so that is represented here. I write for here a0 is equal to 3 pi by 2 divided by 2, that is called for the 4. Okay, then plus summation of n equal to 1 to infinity. An is represented as a 0 and minus of 2 by n square pi. For this is even, this is odd. Okay, odd condition of n is even, n is odd. Then multiply with cos n pi plus summation of n equal to 1 to infinity minus of 1 by n sin n of x. We write. So this is represented as a f of x. This is a trigonometric Fourier series of given sum f of x. Next one, the exponential Fourier series. Next example is represented as a expand in a Fourier series of periodic signal 2 pi. F of x equal to x sin x. The time interval fundamental period is represented as 0 less than x less than of 2 pi. Now a0 we take for the trigonometric Fourier series only. Trigonometric Fourier series. So the trigonometric Fourier series f of x, I should write for the a0 summation of plus summation of e of n sin omega 0 of, this is t, that's why I write for the x, plus summation of n equal to 1 to infinity b of n cos omega 0 x we write. Okay, now what is that a0? A0 is equal to this term, a0 equal to 1 by pi integration of c to c plus 2 pi. That is a starting stage and this is the ending stage of periodic signal. F of x dx. We should substitute this value. F of x is equal to x sin x. This is represented as a UV, integration of UV du method. So first take it out for the 1 by pi is common. X sin is represented minus of cos x minus of 1. X again it will be differentiate with 1 minus of sin x. In the limit is represented 0 to 2 pi. After substituting all limit, we get it for the a0 equal to minus of 2. Then next case, we need to find for the a of n the trigonometric Fourier series. A of n formula we know 1 by pi integration of the starting of periodic signal as well as of ending of periodic signal c plus 2 pi f of x cos nx dx. Then we should substitute for the f of x what we have received these values. So 1 by pi integration of 0 to 2 pi x sin x cos nx dx we write. So this term it's represented as a sin x cos nx. Okay, this is I should write the value of sin of n plus, that is we write as a n plus of 1, then minus of sin n minus of 1 we write. Okay, in divided by, that is we make to write for the 1 by 2. 1 by 2 sin of n plus 1 minus of sin of n minus of 1. This formula we can utilize to here. So 1 by 2 pi, this 2 I take it out, that 1 by 2 pi integration of 0 to 2 pi, that is x is a sin nx plus 1 x minus of sin nx minus 1 x dx we write. Now this term you can see that is x is there, that is you can inside the x what will be happen, the x sin n plus of 1 x we got. This is equal to integration of u v dash du is represent. So you can represent as the interval as 0 to 2 pi. So you can, we make to integrate, then after substituting the interval of 0 to 2 pi, we get to simplify for this equation. Finally, we got for the output as a of n is equal to 1 by n square minus of 1 when n is not equal to 1. Okay, when n is not equal to 1, the a of n is present for the 1 by n square of minus 1. Same like that one, we need to find for the b of n also. Before that, we can find for the a1. What is the a1? So that means n equal to 1. So what happened? So n equal to 1 is represented as here. Here we write as the cos of n. Okay, this value is equal to 1. As a formula, what will be write for here? Now, here I write as a a1. So where the n is there, we should substitute for the 1. Here also we substitute for the 1. Okay. So now we got that equation. The a1 equal to 1 by pi 0 to 2 pi x sin cos nx is there. N value is equal to 1 now. So that's why 1 into x is represented as x only dx. Then this is integration of u dash v dv condition is there. And the formula we may utilize, then you can integrate. After that substitute the interval of 0 to 2 pi. We got the output is a1 is equal to minus 1 by 2. Okay. Then we need to find for the b of n. The b of n, we know the formula 1 by 2 pi integration of 0 to pi f of x sin nx dx. So f of x is equal to x sin x. Okay. So then we make to, this is represent as a sin x sin, that is a sin x sin nx is there. That's this equation. There is sin of nx, that is sin of nx into sin of x is there. So this equation we need to, the trigonometric equation we need to write. So I write sin of x sin of nx. This value is equal to 1 by 2 of cos n minus of 1 minus of cos n plus 1. You can utilize this formula for to simplify for the integration. So the multiplication is going to convert for the single case of integration. So now 1 by 2 pi. So this 1 by 2 is take it out. That means 1 by 2 pi is 0 to 2 pi x cos n minus of 1 x minus of cos n plus of 1 x dx. Now we make to do for the integration as per the integration of uv dv method. Substitute for the interval of 0 to 5. Finally, we got for the b of n equal to 0 when n is not equal to 1. Okay, now the b of n, that n value is equal to 1, you can substitute for the n equal to 1. What will be happen as the equation sin nx is there here, so that n value is equal to 1 here. That's why I should write, or I should modify for the our equation as 1 by pi of integration of 0 to 2 pi x sin x dx is there. So that this two, what will be happen? It came for the sin square of x. Now the sin square of x equal to 1 minus of cos 2x divided by 2. Okay, this formula we may utilize for here. So now the integration will be going to happen for the 1 by pi 0 to integration of 0 to 2 pi x of 1 minus of cos 2x divided by 2 dx. Now this is going to have a uv integration of uv dv method is there. Then make to use for that method to integrate. After that, you can substitute for the interval of 0 to 2 pi. Then finally, we get the solution of b of 1 equal to 5. Okay. Now we find for the both the signals. What are the signals? A0 we find A0 equal to minus 2. A of n we find that value is equal to 1 by n square of minus 1. It's n is equal to not a 1 condition. Then based on that condition, we find for the A1, the A1 equal to minus of 1 by 2. After that, we using for the trigonometric Fourier condition of b of n, we find b of n equal to 0 when n is not equal to 1. That condition, we need to find for the b1. b1, we substitute the n equal to 1 in the f of x. We substitute and make to integrate to apply, submit for the interval of 0 to 2 pi. Finally, we got the b of 1 equal to 5. Okay. Therefore, the Fourier series expansion of function x of sin nx is given by f of x equal to a0 by 2 plus summation of n equal to 1 to infinity an cos nx plus bn sin nx. So, f of x equal to x sin nx. Then that value is equal to 1 minus of 1 by 2 cos. So, we substitute for the a0 an bn. So, 1 minus of 1 by 2 cos x plus 2 summation of n equal to 2 to infinity cos nx n square of minus 1 plus pi sin nx. This is represented as a Fourier series of trigonometric condition given signals. What we are given signal? X of sin x. Okay, this is a given signal. This is simplification. Next case, obtain the all Fourier series coefficient of f of x equal to k, where k is a constant, the periodicity being 2 pi. Here they are going to given their periodicity because of the Fourier series. It's possible to do for only the periodic signals. So they given in the question itself, they given the signal is periodic. Now we find for the k values. Okay. Now as per the statement of trigonometric Fourier series, we need to find for the a0, an as well as the bn. The a0 is equal to 1 by pi integration of c to c plus 2 pi f of x dx. Because of they given for the limit, that is 2 pi. That's why starting as well as the ending is represented 2 pi. So now we may write as 1 by pi integration of 0 to 2 pi k dx. F of x equal to this value. The f of x equal to k. Substitute the k. So you take it out, k is a constant 1 by pi x, that is dx integration is x. The limit is 0 to 2 pi. Then you substitute for the limit. First k by pi, 0 is the 2 pi minus of 0. That 0 no need. So this 2 pi are getting to cancel. It's represented as a0 equal to 2k we write. Next, we go for the a of n. A of n we know 1 by pi integration of c to c plus 2 pi f of x cos nx dx. We write dx we write. That value is equal to 1 by pi 0 to 2 pi k cos nx dx. The k by pi sin nx divided by n. If we make to integrate for this one, sin nx by x, we substitute for the limit. For the limit 0 to 2 pi. So sin 2 pi n minus of sine 0 divided by pi. This value is represented as a 0. If you substitute for anything in the sine terms of the n value, it's represented as 0. So k into pi 0, that is this term is represented as 0. Then k into pi, k divided by pi 0, we write as a of n equal to 0. Next we need to find for the b of n. B of n is equal to 1 by pi integration of c to c plus 2 pi f of x sin nx dx we write. So that value you can write as 1 by pi f of x equal to k sin nx dx. Then k take it out, k by pi integration of 0 to pi sin nx dx. What is sin nx dx integration? That will be represented as a minus cos nx divided by n. This should substitute for the interval. The interval is 0 to 2 pi. Here is k by pi cos 2 pi n minus of cos 0 divided by pi. That is k by pi. This is, you substitute for anything, this represents 1. K equal to 1 to 3 because of multiplication of 2 is there. So 1 minus of 1 divided by b of n also is represented as 0 after simplification case. So now a of n 0, b of n 0 as a trigonometric Fourier series. The function f of x said to be even, f of minus x equal to f of x. The function f of x said to be odd, f of minus x equal to minus of f of x. If f of x is an even function with period of 2 pi, the interval I write as a minus pi to plus pi, then f of x can be expressed as a Fourier series. The Fourier series of f of x equal to a0 by 2 plus summation of n equal to 1 to infinity a n cos n x. So this condition bn equal to 0. Okay, for even function. So what the evens are there, then only this is going to even value. Now next case, if you get for the odd value, that will be case is represented as 0. Okay, we know a0 and an. b0 is represented as 0. See, we find a0 is equal to 2k. A of n also 0, b of n also 0. So we don't want for the b of n. Okay, so we go for the, based on the result, based on the Fourier series coefficient, the signal is dominate with only the even part. That's why I take for the even part only. There is no possible to dominate for the odd part. So that's why I write as a f of x equal to what the term a0 divided by plus of summation of n equal to minus plus a n cos n x I write. Where Fourier series coefficient a of n, a of 0 as well as a of n are calculated. A of 0 equal to 2 by pi integration 0 to pi f of x dx. A of n equal to 2 by pi integration of 0 to pi f of x cos n x dx we write. Okay, this is the condition. Next condition, if the signal is odd, okay, if fx is a odd function with period of 2 pi, its definition of it's defined minus pi to plus pi, then f of x can be expressed as a Fourier sine series. Here f of x equal to only is present for the b of n term, that is n equal to minus plus into b of n sin n x, where b of n is represented as a Fourier series coefficient. We calculated that b of n equal to 2 by pi integration of 0 to pi f of x sin n x dx. Okay, so this is represented as a even as well as a odd condition. Okay, what we concluded for this one. So finally we concluded for the our output is present for the trigonometric Fourier series condition only the even part. Okay, what the even part? F of x equal to a0 divided by 2. A0 we find what is that? 2 of k. 2 of k divided by 2. Both are getting to cancel. Now what will be happen? F of x equal to k. Now it's going to satisfy for the our condition. Okay, what is the condition? If the signal is even, it's produced for the only even signal, and if signal is odd, if the signal is represented as a minus of fx, it's getting to reverse. Okay, now what we received from the our case, f of k we received, then k is a constant. That case, the produced output is of Fourier series is also it we have the k equivalent value. So the signal, what you are going to receive the signal in the sum, that is represented as a even condition. Next case, derive the Fourier series of f of x equal to x plus x square. The interval present for the minus pi to plus pi. The period of the total interval is equal to 2 pi, and hence deduce the equation summation of 1 by n square equal to pi square divided by 6. Okay, we need to prove like this one. Here also we take for the Fourier series in the trigonometric condition. A0 we write it the formula 1 by pi integration of minus pi to plus pi f of x dx. Here we receive the minus pi to pi. That's why directly we write. Don't want to write for the integration of c plus c, that is c plus of capital letter T. So we receive like this one, then we write it for the rep. Then after we substitute the value of f of x. So 1 by pi integration of minus pi to plus pi x plus x square dx equal to 1 by pi x square by 2 plus x cube by 3 interval of minus pi to plus pi. After substituting the interval, we can simplify for the values. Then a0 we got for the 2 pi square by 3. Then at the same time, a of n also we use for the Fourier series coefficient formula, that is 1 by pi integration of minus pi to plus pi f of x cos nx dx is equal to this f of x is represent for the x plus x square. We can substitute for the x plus x square to here. Then we can distribute for this x plus x square. Then after you do for the integration. Then after integration we substitute for the interval of minus pi to plus pi. Finally we got for the a of n is equal to 4 divided by n square of minus 1 whole power n. Next we find for the b of n also. Same formula. What they are going to using in the trigonometric Fourier series 1 by pi minus pi to plus pi f of x sin nx dx. We can substitute the f of x equal to x plus of x square. Then after we make to integrate and substitute for the interval of minus pi to plus pi. We get it, the answer is b of n equal to 1 by, that is 1 by n 2 into minus 1 whole power of n plus of 1. The Fourier series coefficient we write for the trigonometric condition as f of x equal to a0 divided to plus of summation of n equal to 1 to infinity a n cos n x plus b n sin n x. We can substitute for the a0, a n and b n, and finally you can simplify the equation that f of x equal to pi cube by 3 plus summation of n equal to minus 1 to plus 1 summation of n equal to 1 to infinity 4 by n square minus 1 whole power n, that is a of n cos n x plus b of n is represented 2 by n minus 1 whole power n plus of 1 sin n x. Right. This is a solution of given equation. Next case, we go for the deduction. For the deduction, the end point of the range is present for the plus 5 and minus 5. Okay. X, the end point of periodic signal, plus pi to minus of pi. They given pattern or sum. Okay. Here what they going to given? The end point of the signal is present for the minus pi to plus pi. Now we take for the minus pi to plus pi. Therefore, the value of the Fourier series x present for the pi is the average value of f of x at the point x equal to pi and x equal to minus pi. Hence, the average value of f of x I should take for the x equal to pi only. Okay. If x equal to pi, what will be happen? F of minus pi divided by 2. Because of this pi is represents a half signal. Though minus pi divided by 2 is equal to pi squared by 3 plus 3, 4 summation of n equal to 1 to infinity 1 by n square minus 1 whole power n cos n pi. Okay. Only we take for the half signal. Next case. This case, what is f of minus pi by 2 is represented as a pi plus a pi square. X equal to minus pi. We are substitute. As a equation, what you are using? X plus of x square. Okay. So this x plus of x square going to work for the x and minus of x. Both the conditions. So this is represented as a this case pi plus of pi square. Okay. Pi is equal to next case plus minus direction. Minus of pi plus minus of pi whole square. That is equal to minus pi plus pi square divided by 2. This is equal to pi square divided by 3 plus 4 summation of n equal to 1 to infinity 1 by n square minus of 1 whole power 2n. I should write. So why I make to write? This is n term. It's represented as a 1 power n. Here minus 1 power n. So that's why I concluded for the minus 1 whole power n. This is minus 1 whole power of n. That's why I concluded for the your equation is pi cube. That is pi square divided by 3 plus 4 summation of n equal to 1 to infinity 1 by n square minus 1 whole power 2n. Now we can simplify this value. What is it? 2 pi square by 3 plus that value is equal to 4 summation of n equal to 1 to infinity 1 by n square. Then finally I concluded this value I write as a summation of n equal to 1 to n 1 to infinity 1 by n square equal to pi square by 6. Okay. So this is represent for the what we are going to receive from the equation, that is deduction point. We got it for here. So 1 by from the sum the summation of 1 by n square equal to pi square by 6. We take received from summation of n equal to 1 to infinity 1 by n square equal to pi square divided by 6 we got it. Okay. This is the way we are made to represent for the deduction of the signal, whether it's odd as well as even in the Fourier case. Another example I should take, we go for the first 3 harmonic of Fourier series. Okay. In this case, they given for the tabular column, the x as well as f of x. X is represented as the interval. What are the interval they given? 0 to 2 pi they given. Okay. So the same character is going to reflected for the another 0 to 2 pi. Okay. Another period. So we can decide that this one is represented as a periodic signal. What you are going to receive the table, the starting as well as the ending case, the signal is periodic signal. If the periodic, it's suitable for the Fourier series of f of x. Now, in this case, they are asking for the first 3 harmonic. What is the first 3 harmonic? They will ask for the A1, A2, A3. Okay. We make to do for the harmonic, we must do, we make to do for the harmonic, we do for the tabular column formation. That tabular column formation, we take for the point x is equal to 2 pi. Okay. So, x. So, you write it for the this whole x, that is up to 2 pi. So, 0, pi by 3, what you are seeing? Then 2 by 3, pi, 4 pi by 3, pi by 3. F of x equal to 1, 1.4, 1.9, 1.7, 1.5, 1.2. Okay. Now, we need to do for the 3 harmonic. What are the harmonics? So, 1, 2, 3. So, cos x, cos 2x, cos 3x. Even sin also it will be represented as a sin x, sin 2x, sin 3x. So here cos x, sin x, cos 2x, sin 2x, cos 3x, sin 3x. They are asking for the 3 harmonic. Okay, we taken for the 3 harmonic. Then we should substitute for the x values. For here cos x is 0, cos 0 equal to 1. Same like that, we may substitute for all. We need to fill the tabular column. Okay. After filling the tabular column, we come to here. We know A0 equal to 2 by A0 is represented as a constant. That value is represented as A0 by 2. So what the A0 by 2 we represent for the 2 by 6. Okay, 2 by 6. So what will be what the condition we represent? 2 condition 2 by 6 we got it. Then f of x, that is represented as 1 by 3. As for this state, 1 by n square equal to pi square by 6. So this condition we take it to here, we make it to write for the 2 by 6. Okay. So what otherwise what we do? We need for the 6 harmonic. Okay. This is 1, 2, 3. Total it's generating for the 6 harmonic. What are the 6 harmonic? Cos 2x, cos 3x, sin x, sin 2x, sin 3x. I write that harmonic I take for the 6. So total 6 harmonics are there. A is represented 2 by 6 summation of f of x I write. A0 is represented as a it will be present only f of x. Okay. So there is no coefficient is going to multiply. F of x, what is it? Is represented as a 1, 1.4, 1.9, 1.7, 1.5, 1.2, 1, 2. So that is 1 by 3. These 2 are getting to cancel. That means 1 by 3, 1, 1.4, 1.9, 1.7, 1.5, 1.2. The final result value is equal to 2.9. The 2.9 divided by 2 equal to 1.5, 1.45. Another one, A1, 2 by 6 summation of f of x cos x. So now n is represented as a 1. Okay, so that will be A1 equal to summation of f of x cos x. Here n is there, that value is equal to 1. So same like that on A2 also, 2 by 6 summation of f of x cos 2x. Then A3 is equal to 2 by 6 summation of f of x cos 3x. Then B of 1 equal to 2 by 6 summation of f of x sin x, we can write. This is a cos term as well as a sin term, both will be given. A1, A2 again. Now we can substitute. We know the cos f of x equal to what the value, and the cos x, that is 1 by 6, 2 by 6, 1 by 6. Then as per the table, what is it? X into cos x. Okay, we can 1 plus 0.7 minus 0.95. We can put. Finally we got for the minus of 0.3. Same like that one we find for the all the values. Okay, so then finally we know our trigonometric Fourier series A0 summation of n equal to 1 to infinity an cos nx plus summation of n equal to 1 to infinity bn sin, that is f of x sin bn, like that. We can substitute for the all the value here. Okay, we got it for f of x equal to 1.45. Then a1, that is a1 equal to 0. What is it? 0.3. This is 0.33. Okay, cos x minus of 0.1, that is a. This is a1, a2, a3. This is b1, b2, b3. We should write for the, or that 0 is there. That's why it will be represented as 0. So this is the a1 coefficient, a2, a3 coefficient. This is a b1, b2 coefficient. b3 coefficient is represented as 0. We find by the 0. This is Cn. Then you can substitute. We cut it for the 3-term harmonic of trigonometric Fourier series. Okay. Another case. Here we take for the another example, the value of x and the corresponding value of f of x over the period t are given below. Shown f of x equal to this value they given for us, where 0 is equal to 2 pi x by t. So x value. So we substitute 0, t by 6, t by 3, t by 2, 2t by 3, 5t by 6, t. So after that we need to substitute the value of this equation. We get it for the f of x equal to 1.98, 1.30, 1.05, 1.30, minus 0.88, minus 0.25, 1.9. So now we may make to do for the trigonometric Fourier series corresponding to find the f of x. We omit the last value of sin c f of x at x equal to 0 is known as theta is equal to 2 pi by x divided by tau, where x values are 0 to t and the theta values are 0 to pi, with increasing of 2 pi by 6 condition. Let f of x equal to f of theta, that is a0 divided by 2 plus a1 cos theta plus b1 sin theta. Okay, so remaining term it will be go for the negative. So then based on this equation, based on we find the equation, this equation we make to do for the tabular column, or the tabular column. So theta y cos theta sin theta, y cos theta, y sin theta. So see here what we are going to represent. Based on that one we make to do for the table. The theta values represent 0, y equal to we represent for the 1.9, 1.3, 0.3 minus 0.8 up to pi by 3. Then cos theta. What is the cos theta? It represents cos this value 0, cos 0 equal to 1, pi by 3 equal to 1, 0.5, 2 pi by 3 is equal to minus 0.5, pi is equal to minus 1, 4 pi by 3 equal to minus 0.5, pi by 3 equal to 0.5. Same like that one, sin term, y cos term and sin term. So y term we know this one, and you can multiply for the this term. We got it for the y cos theta. Then next case, So sine plus the y, you got heading for this values. Okay, now we make to do for the average. Okay, summation. So this y summation is equal to 4.6. Then y cos theta is equal to 1.12. Then y sin theta equal to 3.2. Okay, as per the statement of a0 equal to 2 by 6, 1.2 by 6 f of x. What is the f of x? 4.6. Okay, 4.6. This case 2 as well as of 6 is represented 1 by 3. So this 1 by 3 into 4.6 divided by 3 is equal to 1.5. A1 is equal to 2 into what are the values we received? Y cos theta n. Y cos theta 1.21 divided by 6. We got for the A1 equal to 0.37. B1, what is the B1? The B1 is equal to 2 by 6. Then after 3 point y cos sin theta equal to 3.016 equal to 1.004. Then finally we write it for the equation is represented as a f of x equal to 0.75. This is a by 2. Okay, 0.75 plus b of n is represented as a 0.37 cos theta. Then 1.004 sin theta. This is represented as a B1 condition. So next case, find the first three harmonic of Fourier series coefficient when we receive for the y equal to f of x from the following data. So x is equal to 0 to 330 degree, 0 degree to 330 degree. Y also they given for the number, some number. Okay, we need to do for the solution. As the table can be formed usually the way of what is it? We consider for the y is equal to a0 to b2 as a trigonometric Fourier series, summation of n equal to 1 to infinity a n cos n x plus b n sin n x. Means a0 is equal to 2 by 12. How many numbers are there? We have the 12 numbers. 2 by 12. That is previously we taken for the 6 number. That's why 6. 2 by 12 summation of y cos x. Okay, that is a1. If a0 is equal to 2 by 12 summation of y. So what is the summation of y is that? Is represented as a 2425. This total summation is equal to 12. So 1 by 6 into 2425 equal to 404. Next a1 is equal to 2 by 12 summation of y cos x. Okay, y cos x is represented by the 107.043 is value equal to 107. So a2 also same like that, 2 by 12 summation of y cos 2x. a3 also will be similar, a2 by 12 summation of y cos 3x equal to, we write for the directly for the value minus 1.3, 2.0 for a3. Then b1 is equal to 2 by 12 summation of y sin x equal to 127. b2 it will be represented as a 9. b3 is represented as a 1. Now all the things we need to substitute for the values of we get for the y value. Y equal to a0 equal to 202 plus 0.17, that is a1 cos x minus of 13 cos 2x plus 2 cos 3x plus 121 sin x plus 9 sin 2x minus of sin 3x. Okay, like that one we can fill it for all our coefficient. What are the coefficient? a0, an, bn. That peak is a1, a2, b1, b2. Like that one. Then we can substitute those values. Finally, we got this case of our output in the Aeronautical Fourier series condition. Up to this much, I am going to conclude at my section for Fourier series examples. Okay, thank you all.
Like, share and subscribe. Hit the bell icon for more updates.